All right, y'all, these videos I will be covering 2.4 from college algebra and then 9.1 from college algebra. So let me share my screen and get to our notes. All right, so first we're going to cover 2.4, and that deals with the algebra of functions. All right, so there's four types of algebra we're going to look at with our functions. So number one, we're going to look at f plus g of x. What that tells me to do is take my f of x function and add that to my g of x function. So basically, you'll take both the functions, add your like terms, and be done. Second one we look at will be f minus g of x, which will be my f of x minus my g of x. Okay? So you got to be tricky on subtraction, because if you got functions, we're going to put them in parentheses, and you got to distribute those negatives. So I'll show you what I'm talking about a little bit later. Number three will be f times g of x. And right, that's just going to be what? F of x times g of x. So when you're multiplying functions, there's a few rules we'll have to go over while we're doing those, okay? And then number four will be f divided by g of x. And that'll be my f of x divided by g of x. Now, I got to make sure one thing. I got to make sure that the g of x part does not equal 0. Because if g of x equals 0, that would make that undefined, okay? So, let me show you what these examples are going to consist of. So for my first example, I'm given f of x equals x squared plus 3. G of x is going to equal x plus 2. They want us to find f plus g of x. Okay? So notice they're not giving me a number at the moment. They just want me to find f plus g of x. So f plus g of x is going to equal f of x plus g of x. All right, so what I do on these is I take parentheses and I replace each function with parentheses, and then I put what it gives me for the functions inside my parentheses. So my f of x here was an x squared plus 3. My g of x is an x plus 2. Now, since these are in parentheses and you're adding, we can now drop the parentheses and get an x squared plus 3 plus an x plus 2. Now later on, when I'm multiplying and subtracting, you'll see why I really need the parentheses, okay? All right, so now, the only thing you can do on this is add like terms. So the x squared would add to any other x squareds in here, and you don't have any others, so bring down that x squared. Now, I'm going to put mine in what I call descending order. So next I'm going to look at the x's. I've only got one x in here, so I'm going to bring down that one x. But now look at this. I got a number 3 and I got a number 2. 3 and 2 can be added together, and 3 plus 2 would give us 5. Now, if you went in order and did the x squared, and then you did the 3 plus 2 and put your 5 here, and then brought down the x, it would take that answer unless it tells you to put them in descending order. I just do that because later you will have to know what the descending order is to do these, okay? All right, since I don't have any more like terms, that problem's done. All right, y'all, next one they give us f of x is going to equal x squared plus 4. G of x is going to equal x minus 1. This time they want us to find f times g of x. So sometimes they'll put the letters right next to each other for multiplication, and then sometimes they'll actually throw that dot in the middle, okay? All right, so here we go. F times g of x is going to equal f of x times g of x. All right, f of x. Now, since these are going to be parentheses, I don't need to put the dot in the middle because I know that by putting my parentheses next to each other, that means multiplication. So I'm going to put f of x in the first one, which is my x squared plus 4. Then I'll put my gx in, which is the x minus 1. So when you got things like this in parentheses with more than one term, you got to FOIL this, okay? Now remember, when you multiply variables, you treat this variable like it's got a 1 here, and when you multiply variables, you add those exponents. So what you want to come in first, to FOIL this, you take the x squared times the x1. That's going to give you an x. 2 plus 1 is 3. So I get an x to the third. Then you would take that x squared times that negative 1. Well, negative 1 times x squared is a negative x squared. So see, you just distributed the x squared. Now you got to distribute the positive 4. So the 4 times the x is just a positive 4x. And then you take the 4 times the negative 1, and 4 times negative 1 is a negative 4. All right, so let's see. Look at this. We got an x to the third, x to the second, a 4x, and a 4. None of those are like terms. So since I do not have any like terms on this, that is my final step. So y'all, these aren't too bad. You just got to watch how you write them out initially, and then remember to do that FOILing when you got these parentheses. All right, so this next one, I'm going to have f of x equals x squared minus 2. G of x is going to equal x plus 3. We're going to find g times g of x. So a little tricky one here, right? But remember, g times g of x is going to equal g of x times g of x. So they gave me f of x for no reason on this one because all they want me to do is take my g of x times my g of x. So here we go. Replace those with parentheses. And remember, I don't need to put my dot this time because I got parentheses times parentheses. G of x is x plus 3. G of x is x plus 3. So both of those have an x plus 3 in them, okay? So we're going to FOIL again. So remember, these x's have a 1 by them because when I multiply the x times the x, I get an x. 1 plus 1 is 2. So that took care of that. Then I do x times 3. That's 3x. Now we take this 3 times the x, and we get another 3x. And then finally, y'all, I take the 3 times the 3, which gives me a positive 9. Oh, so look at this one. You do have like terms that can be added. So we bring down the x squared. Here we got 3x's plus 3x's. Now remember this. When you add like terms, you cannot change the variable. All you can do is add the numbers. So that's going to give me a positive 3 plus 3 is 6. Bring down the x's. 3x's plus 3x's is 6x's. You cannot make that an x squared, which is the common mistake. And look here, you got a 9 at the end. No other like terms for it. So bring down that 9. Now, no more like terms. So we are done. All right, y'all. Let me go to the next page. Remember, if y'all need more time on copying those, just hit the pause on these, okay? All right, f of x is going to equal negative 16x plus 4. G of x is going to equal x squared plus 18. They want me to find f of negative 7 plus g of negative 7. So notice this time, I don't have x's in this. They gave me numbers. So f of negative 7 plus g of negative 7 is going to equal f of negative 7. I'm going to put this in parentheses plus my parentheses. Now, when I put this one in there, since they're putting a negative 7 here instead of x's, when I rewrite this, I got to replace these x's with a negative 7. So this one will be negative 16 times negative 7 plus 4. Everything else comes down. All you do is put a negative 7 in for that x. And this one will be negative 7 squared plus 18. Now, I always put my negative numbers in extra parentheses because you got to square that negative also. Now, since you got these big sets of parentheses, you're going to have to work inside of each one of those first. We got to turn these into single numbers before we can add them, following our order of operations. So, the first thing I'm going to do here is multiply negative 16 times negative 7. So I got my calculator here. Negative 16 times negative 7 is going to give me 112 plus 4. So all I did was multiply. Over here, I'm going to figure out what negative 7 squared is. So parentheses, negative 7, square that is going to equal 49. So that gives me 49 plus my 18. Now notice, you can still work inside these parentheses, but since this is the last step, I can now drop the parentheses. So 112 plus 4 would give you 116 plus 49 plus 18 is 67. Now, I got a single number, I can now add them finally. So 116 plus 67 is going to give me 183. Final answer. Okay, y'all, so they're not that bad. You just got to follow that order of operations, okay? Now, you can put these into calculators just like that, and it'll spit out that answer quick, okay? All right, this one I got f of x is going to equal negative 16x plus 19. G of x is going to equal x squared plus 18. Ooh, same number as the last problem. This time, though, they want me to find f of negative 6 minus g of negative 6. So a little bit of subtraction on this one. So I know my f of negative 6 minus g of negative 6 is going to equal my first parentheses minus my second parentheses. My first parentheses, I'm going to replace these x's with negative 6's. So I got negative 16 times negative 6 plus my 19. And then over here, I got negative 6 squared plus 18. So since I got a lot of steps, I'm going to bring down my parentheses still. So the first thing I'm going to do is multiply negative 16 times -6, and that's probably 96. So I get a 96 plus 19. Over here, we're going to see what -6 squared, and -6 times -6 is 36 plus my 18. So now remember, since I'm going to get one number out of both of these, I don't need the parentheses no more. So that 96 plus 19 is going to be 115 minus 36 plus 18 gives me 54. So now y'all watch this. I'm going to take that 115 minus my 54 for a final answer of 61. Okay. So like I said, once again, you could plug this right into the calculator and it'll spit them answers out. Also, I'm going to send a video on how to do these in different methods on that calculator also, okay? I think I got those in the Blackboard shell under my weekly videos. If you'll look in the lecture videos, you'll find one that says doing this section with the calculator. All right, let's see. F of x equals -20x plus 15. G of x is going to equal x squared plus 11. I'm going to find f of 1 times g of 1. All right, so since these are multiplying and I put my parentheses, I don't need to put the dot. So f of 1 will be the f of x, -20. In place of the x, we put a 1 and then bring down to plus 15. Over here, since 1's positive, I'm just going to write 1 squared plus 11. So I don't really use parentheses around positive numbers, but I definitely do around negative numbers, okay? All right, so I got a lot of steps. So I'm going to bring these down in parentheses still. -20 times 1 is -20 plus 15. 1 squared is 1 plus 11. So notice I'm doing the highest priority every time. Parentheses, exponents, multiply, divide, add, subtract. All right, so in this parentheses, we can still work. -20 plus 15 is a -5. Now, I'm writing parentheses on these single numbers because I know I'm going to keep multiplying, okay? And it saves me from having to write that dot, I guess. And in this parentheses, I had 1 plus 11 is 12. All right, my final number will be -5 times 12, which is a -60. So remember, unlike signs, when you multiply, will give you a negative answer. All right, let's see. F of x is going to equal -17x plus 13. G of x is going to equal x squared plus 14. I'm going to find f of 2 divided by g of 2. All right, so f of 2 divided by g of 2 is going to equal my f up on top divided by my g on the bottom. So on top, I got f, which is a -17, times my x, which is 2, plus 13. On bottom, I got my g, which is x squared, so that'll be 2 squared plus 14. All right, now, if I was doing this on the calculator, I would actually put parentheses around the top and the bottom to get this right on it, okay? So let's see, let's bring that down. On top, first thing I'm gonna do is multiply. -17 times 2 is a -34, plus my 13 on top. On bottom, I'm gonna square the 2. 2 times 2 is 4, so that gives me 4 plus 14. All right, negative 34 plus 13. 34 minus 13 is 21. Larger number is negative, so that stays negative. And then on the bottom, 4 plus 14 is 18. Now, the last thing you would do would be to reduce that. So both these numbers have 3's in them. So you divide the 3 out of the top, you get a negative 7. Divide the 3 out of the bottom, you get a 6. So that the final answer is a negative 7 over 6. All right, y'all, moving on. F of x is going to equal negative 4x plus 2. G of x will equal x squared plus 3. They want me to find f plus g of x. So it looks like they're starting to get back into just putting a variable here instead of numbers, okay? So f plus g of x will equal my f of x plus my g of x. F of x is negative 4x plus 2. G of x is an x squared plus 3. All right, so since we're adding, we can drop the parentheses, negative 4x plus 2 plus the x squared plus 3. And remember, since we're adding, all we can do is add like terms. So I'm going to start in descending order again. So I'm going to bring down the x squared because it has nothing else to add to. Next, we're going to look at the x's. And the negative 4x has nothing else that looks like x's. So I'm going to bring it down. But look here, you got a number that will add to a number. And let's see, 2 plus 3 will give us 5. Final answer. No more like terms, so we're done. All right, let me let y'all catch up when I get a drink. All right, next one, let's see what I got. I got a f of x is going to equal 4x minus 3. G of x is going to equal 7x minus 6. We're going to find f minus g of x. Now, you might not have to put them in parentheses when you're adding, but you better put them in parentheses when you're subtracting. Watch this. In place of the f of x here, I'm going to put the 4x minus 3. In place of my g of x, I'm going to put 7x minus 6. So remember, f minus g of x is f of x minus g of x. Now, the first part, yeah, you don't have nothing in front of that, so you can drop those parentheses and bring down that 4x minus 3. But anytime you got parentheses following subtraction, you got to take that negative and distribute it. And we treat it like a negative 1. Negative 1 times 7x would make that a negative 7x. And then when we treat that negative 1 over here times that negative 6, two negatives make that a positive. So notice, inside the parentheses, it was positive. Following subtraction, it came out negative. Inside the parentheses, it was negative. Following the subtraction, it came out positive. All right, now that I got rid of my parentheses, I can add like terms. So I got a 4x and a negative 7x. 4 and negative 7 give me a negative 3x. So remember, the x stays the same. And then we got a negative 3 that'll add to that positive 6. Negative 3 plus 6 is a positive 3. 6 minus 3 is 3. Larger number is positive, so it stays positive. Now, x's don't add to numbers, so that would be my final answer. But y'all, I will say the biggest mistake I get, people leave this thing negative and they get the wrong answer at the end because of that negative, okay? All right, let's see what we got next. All right, f of x is going to equal negative 2x plus 2. G of x is going to equal x squared minus 3. They want me to find, now watch this, g minus f of x. So I will write this one out because g minus f of x means g of x minus f of x. So that's going to be my g minus my f. My g is x squared minus 3. My f is the negative 2x plus 2. Remember, now I'm subtracting, so I will, when I rewrite this, distribute that negative. So first parentheses, nothing in front of them, I can drop them down, x squared minus 3. I'm going to treat this like a negative 1 again. Negative 1 times negative 2 is a positive 2x. And then that negative 1 times that positive 2 makes that a negative 2. So once again, both these signs changed. Now, add like terms. So I got an x squared here, nothing else to add to, so I'm going to bring it down. Then I'm going to do my x's. I got a 2x, nothing else to add to, so I'm going to bring it down. Now I got a negative 3 that'll add to that negative 2. Negative 3 plus negative 2 is negative 5. Remember, when you add like signs, you add the numbers and you keep that sign, okay? All right, y'all, let's see. That was g minus f. All right, so 11, they're doing the same. So I'm going to skip and do this one. I got f of x is going to equal x squared minus 8. G of x is going to equal 2 minus x. They want me to find f plus g of a. Okay, so that means I'm going to find f of a plus g of a. So I'm going to put them both in parentheses. So when they put an a here instead of x, they want me to replace these x's with a. So this will be a squared minus 8. This one will be 2 minus a. So they look the same. We're just replacing it with another letter instead of that. Now, since they're being added, I can drop all my parentheses. So I got a squared minus 8 plus 2 minus a. And y'all, the last thing I can do, add like terms. So the a squared has nothing to add to, so I'm going to bring it down. Then I got this minus a. It has nothing to add to, so I'm going to bring it down. But now I got a negative 8 that will add to the 2. And a negative 8, positive 2 will give me a negative 6. 8 minus 2 is 6. Larger number is negative, so it stays negative. All right, so let me get another page because this last one I'm going to do says for the pair of functions f and g, we're going to find the sum, difference, and product given f of x equals x squared, and g of x is going to equal 3x minus 10. All right, it also looks like once we find all of these, we're going to also find the domain of each. Okay, so that's where we did we had the set builder notation, and we said x is a real number and x couldn't equal 5, or x had to be greater than something. Okay, so let's first find the sum. The sum is going to be f plus g of x. That's going to equal my f of x plus my g of x. F of x is x squared. G of x is 3x minus 10. All right, we're adding, so we can drop parentheses. And when I drop parentheses, I have no like terms, so that would be my final answer for that. Now it's going to ask me for my domain. I think on MATLAB it asks the domain right after that. And these ones will have blanks, and they'll have the x such that x is a real number. And since I didn't have any fractions on this, I know it works for all real numbers, and I'm done. Remember, if this was a fraction, I would have had to set it equal to 0 on the bottom and find out what numbers might make it undefined. But I didn't have a fraction. That was just a trinomial, so we're good. So now let's find f minus g of x. That's going to equal my f of x minus my g of x. F of x is x squared. G of x is 3x minus 10. Now remember, when I drop these parentheses, I'm going to treat that like a -1 and distribute. So I get an x squared. -1 times 3x is a -3x. -1 times -10 is a +10. No more like terms, so I stop there. So my domain, once again, I don't have any fractions, so my domain will be x such that x is a real number, right? Because I can square any real number, and I can subtract any real number. So there's nothing that'll make that undefined or imaginary, okay? And then the last one we had was what? F times g of x, which is the product. So f times g of x is going to equal my f of x times my g of x. F of x was x squared. G of x is 3x minus 10. So anytime you got one thing times two things, you got to distribute. So remember that x has a 1 there because I'm going to multiply variables. X squared times 3x is a 3x. 2 plus 1 is 3. So the variables, you got to add the exponents. And then you take that x squared times -10. That's going to give you a -10x squared. Now look at that. These are not like terms because x3s do not subtract x squareds. So we're done. No further can we go. So the domain, you got it. Once again, there's no fractions and no radicals to worry about. So this is good for all real numbers again. Okay? Because we want you to understand at this point, the only thing we're worried about on a domain is a fraction because that bottom can make a 0, okay? Now, had I been doing this, and I did division, if you did, now they're not going to ask you this, but if I had f divided by g of x, that would equal my f of x, which is x squared, over my g of x, which would be 3x minus 10. On this one, I would have to worry because I got a fraction. So what I would do is take my 3x minus 10 and set it not equal to 0 because it cannot equal 0. So we would solve this by adding 10. And I would get 3x cannot equal 10. And then divide by 3 so that we get our x. Those cancel, make a 1 like we needed. That cannot equal, let's see, 10 and 3 have nothing in common, so that's not going to reduce. So in this case, x couldn't be a 10/3 because if you put a 10/3 in there, you would get a 0, and we cannot divide by 0. So that domain would be like this, x such that x is a real number and x cannot equal 10/3. So had I given you division on this, which they don't on this question, we would have had to set the bottom only. Notice, I don't care what's on top. You can have a 0 on the top. You just cannot have a 0 on the bottom. Okay? All right, so that concludes 2.4. So we're about to start 9.1. So let me stop the share for a second. Let y'all take just a little break here. All right, y'all, so now we're going to start 9.1, and it deals with what we call the composition of functions. So the symbolism we use to represent the composition of functions will be f compose g of x. Now that's like a little degree symbol. It's not multiplication or nothing like that. It's a degree looking symbol, okay? So that really means f of g of x, which means you take a function and you evaluate it and you take its answer and put into the other function, okay? So you would always start with the innermost function and work your way out. Okay, so you'll see this sometimes in your sciences. You might have a formula for force, but before you can find the force, you got to know what the acceleration is. So you might have a different formula that finds the acceleration. Once you find the acceleration, you put it in to the formula for the force. Okay, so let me show you how we work these. So on these ones, they give you f of x, which equals negative 3x minus 1, and then they give me a g of x, which equals x squared plus 3. They want me to find f of g of 6. So they're giving me a number to put into this, okay? So what I would do, this is really like f of g of 6. So since g's by the number, that's the first one I got to figure out. So the first thing you figure out, what is g of 6 equal? So you take the g equation, x squared plus 3, and you put that 6 in for that x. So that'll give you 6 squared plus 3. All right, so working this order of operations, 6 times 6 is 36 plus 3. 36 plus 3 give me 39. Now that we know that this g of 6 part equals 39, we take that 39 and put it into the f equation. So we're going to find f of 39. That's going to equal negative 3 times 39 minus 1. So it looks like f, but it's got the 39 now instead of the x. All right, so let me see. I got negative 3 times 39. What's that? Negative 117 minus 1. And negative 117 minus 1 is what? A negative 118. Final answer. Oh, y'all, I did it again. I didn't share my screen. So let me go back and do this. All right, so I started out talking about the composition of functions. So we use this f of g of x to represent the composition function, okay? So what this means is that you have a f of g of x. So you sort of take this one on the right and you take this function and put it into the f function. So if I was going to work this, I have to work innermost parentheses first and then work my way out. So on my example I was doing, I was saying they gave me f of x equaled negative 3x minus 1, and g of x equaled x squared plus 3. They wanted me to find f of g of 6. And then I was wanting to also let y'all know that that's not multiplication. That's just like a degree symbol there, okay? So f of g of 6 is really f of g of 6. So the first thing I got to do is find g of 6. So I came over here, and to find g of 6, I take the g equation and put a 6 in for its x. And then I said I'm going to work order of operations. 6 times 6 is 36 plus 3, and 36 plus 3 gave me 39. So since this g of 6 gave me 39, I now take the 39 and put that into the f equation. So we're going to find f of 39. I always put what number I'm finding right here. So that's going to be what? Negative 3 times that 39 minus 1. All right, negative 3 times 39 gave me negative 117 minus 1. And then 117, that's negative, minus 1 gave me negative 118. Final answer. All right, so sorry about that. I get off on these once in a while with that screen share. All right, number 2, f of x is going to equal 3x plus 3. G of x is going to equal x squared minus 2x minus 3. I'm going to find g of f of 6. So it looks like 6 is my popular number today, right? All right, so this one really means g of f of 6. So the order's reversed over here, so notice how I rewrote it over here, which means the first thing you got to find is that f of 6. So f of 6 will equal my f equation, put in a 6 for the x. All right, order of operations, I multiply, that's going to give me an 18 plus 3, which gives me 21. So since f of x is 21, I take the 21 and put into the g. So we're going to find g of 21. Woo, that's going to be big, y'all, because I got 21 squared minus 2 times 21 minus 3. So that 21 has to go in for both of the x's. All right, so I'm from Arkansas, so let's see, 21 squared is going to give me 441, minus 2 times 21 is 42, minus 3. All right, so here we go. 441 minus 42 minus 3 equals 396. Final answer. So they're not bad once you see what's going on with these, okay? All right, so I'm going to pull this page. Remember, if you need more time, just pause me. All right, next example. F of x is going to equal 5x plus 3. G of x is going to equal x to the third. I'm going to find f of g of a negative 4. So remember, this one's what? F of g of negative 4. So I got to do the g of negative 4 first. So g of negative 4 wants me to take the g equation, which is x to the third, and replace the x with a negative 4. Now, since I got a negative number, I'm going to put it in parentheses. All right, so negative 4 to the third power is going to equal negative 64. So now, since that equaled negative 64, I put that into the f equation, and I find f of negative 64. So the f equation is 5 times x, which is negative 64, plus 3. All right, so negative 64 times 5 is going to give me negative 320 plus 3. So take that answer, add 3 to it, and we get a final answer of negative 317. Oh, look at this, number 4. We're going to find f of g, but then we're going to find g of f of x also, and then we're going to find the domain of each. So f of x equals, where you at? X plus 19. G of x equals x minus 19. So I'm going to find f of g of x, g of f of x, and then the domains of each. Now I'll probably do the domains after I do each of these, okay? But I don't know what order they'll ask you these in. But here we go. F of g of x equals f of g of x. So the first thing I do is I find my g of x, but notice they're not giving me a number to put in this time. So g of x is equals x minus 19. Since I can't simplify this x minus 19 is g of x, and that whole thing will go into the f of x, which means I'm going to be finding f of x minus 19, since that's what my g of x is. So f was x plus 19. Remember, in place of the x, so there's my x plus 19. In place of the x, I put x minus 19. All right, so let's see what we get. Drop in parentheses, x minus 19 plus 19. Those like terms cancel, so all that's left is my x. So f of g of x equals x. So the domain on this, you would look at each of these functions. So first, I would look at g of x. There's no fractions, so I don't have to worry about any numbers making this undefined, so I'm good. Then I look at what happens when I put that into my f. Well, no fractions when I work that. So since there was no fractions, there's nothing to worry about. So my domain would be x such that x is a real number. Now, on this one, to represent all real numbers, they want you to use interval notation. So interval notation, I sort of talked about earlier in 2.3, I think it was. But to write all real numbers in interval notation would be from negative infinity to a positive infinity. I think they want you to write them in interval notation on here, okay? All right, so let's find g of f of x. So that's going to be g of f of x. So first, we got to find f of x. Well, since I don't have a number, f of x was up here, and it equals x plus 19. So once again, we cannot simplify this, which means since f of x is x plus 19, this whole thing has to go into the g. So I'm finding g of x plus 19. So I take my g equation, which is x minus 19, and in place of my x, I put x plus 19. So basically, up here when you had numbers, you was putting numbers into that function. Up here, you got polynomials that you can't do nothing to, so you're having to put that whole polynomial into the function. All right, so here we go. X plus 19 minus 19. Once again, the 19's cancel, so I get a final answer of x. So there's no fractions. There's no fractions when I first started up here. So since I had no fractions to worry about, this works for all real numbers. In interval notation, will be negative infinity to positive infinity. All right, y'all, moving on. Remember, once again, pause me if you need extra time. All right, here I got f of x is going to equal x plus 3. G of x is going to equal 2x squared minus 5x minus 3. And we're going to find the same thing. F of g of x domain, g of f of x domain. So f of g of x is going to equal f of g of x. So once again, I don't have numbers. So first I start with my g of x because it's my innermost. And y'all, g of x is 2x squared minus 5x minus 3. There's no like terms. There's no numbers given, so I cannot simplify that. So this whole thing will now go into the f. So we're going to find f of 2x squared minus 5x minus 3, which means in this f equation, wherever I got an x plus 3, wherever I got my x, I'm going to put 2x squared minus 5x minus 3. All right, so let's see what happens. Drop the first parentheses, nothing in front of it. Bring down that positive 3. And the only thing that looks like it's happening on this, these 3's are canceling, so that my final answer is a 2x squared minus the 5x. All right, I didn't have a fraction up here to worry about. I have no fractions down here to worry about. So in interval notation, my domain would be negative infinity to a positive infinity. All right, so what's that give us? G of f of x is next. G of f of x. So that's g of f of x, which means I actually got to start with the f of x on this. See, we switch them around a little bit so that you got to pay attention. F of x was what? X plus 3. Well, unfortunately, we can't make that any shorter. So x plus 3 now goes into the g. So we're going to find g of x plus 3. So the g equation was 2 times x plus 3 squared minus 5 times x plus 3 minus 3. 2x squared minus 5x minus 3. Got to look like that. But remember, both of these x's had to be replaced with x plus 3. All right, so the first thing I got to do is work inside parentheses. I cannot do nothing inside parentheses, so the exponent is next, which means I got to figure out what x plus 3 squared is. So I'm going to FOIL that on the side. X plus 3 squared is x plus 3 times x plus 3. Now you FOIL. X times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. So I distributed the x, then I distributed the 3. Now on this, you do have like terms. So the x squared comes down. 3x's plus 3x's is 6x. And then bring down to 9. So I'm going to replace x plus 3 squared with that. So I got 2 times x squared plus 6x plus 9 minus 5 times x plus 3 minus my 3. So all I did was work the exponent, but remember, anytime you got stuff in parentheses with an exponent, you got to FOIL it. So now you would multiply by distributing the 2 and the negative 5. So 2 times x squared is 2x squared, plus 2 times 6x's is 12x's, plus 2 times 9 is 18, negative 5 times x is a negative 5x, negative 5 times 3 is a negative 15, and then minus 3 comes down. Remember, if you got a negative, you got to distribute that negative. Now all we can do is add like terms. So let's see what I get. The 2x squared has nothing else to add to, so bring it down. My x's do have like terms. So 12x's, negative 5x's give me 7x. And then let's see, I got 18 minus 15 is 3. 3 minus 3 is 0, so those cancel. So the final answer is 2x squared plus 7x. So the domain of this, there's no fractions here on the f of x part. When I worked through this, my g of x had no fractions to worry about. So once again, this is good from negative infinity to positive infinity. All right, y'all, I'm going to do one more of these, and that'll finish out 9.1 for you. This is going to be a tricky one. F of x is going to equal 5 over 1 minus 6x. G of x is going to equal 1 over x. I'm going to find the four things again. F of g of x, domain. G of f of x, domain. So let's work f of g of x, which is going to equal f of g of x. So first I start with g of x. Well, g of x equaled 1 over x. Cannot do nothing to that, which means I got to take that 1 over x and put it into my f. So I'm going to be finding f of a 1 over x. So where they got an x, I'm going to put 1 over x. So I get 5 over 1 minus 6 times 1 over x. All right, so simplifying this one's going to be fun, so y'all pay attention. To simplify this, I'm going to first multiply the 6 times 1 over x. Treat the 6 like it's got a 1 under it. So that this will now give me 5 on top, and then 1 minus 6 over x. So when you multiply a number times a fraction, top times top gave me 6. And then remember, under the 6 was a 1, and 1 times x gave me an x. Now to add the bottom or subtract the bottom, they got to have a common denominator. At the moment, on bottom is a 1 under that 1, right? So their common denominator would be an x. So I would bring the 5 on top over, because I'm just adding the stuff on bottom. So if x is the common denominator, I would multiply the top of the first one and the bottom by x, so that I get an x over x minus a 6 over x. Now, going on, I'm going to bring the 5 down on top. Since these got a common denominator, I could write this part as the x minus 6 all over x. So remember, common denominators, you can rewrite them as a single fraction, or you can take a single fraction and rewrite it as 2 fractions, okay? As long as both of those had that x on the bottom. Now, what we're going to do, I basically got a 5 being divided by x minus 6 over x. But remember, we don't like to divide fractions, so we change those into multiplication and flip the second fraction, right? So see what we get. 5 times x is a 5x on top. 1 times x minus 6 is an x minus 6 on the bottom. So let's see what we got to worry about on this domain. Now you can't go no further on that because we can't factor those and cancel anything, okay? Now, this is tricky, but remember, first thing I did was multiply them, got a 6 over x. Since I was subtracting, they had to have a common denominator, which was an x. So I had to multiply top and bottom by x on that fraction to get the x over x. I rewrote the 2 fractions as 1 fraction down here. And then I rewrote this looking like division, flipped the division, turned to multiplication, and finally got my final answer. So the domain on this one. Well, the first thing, I got 1 over x. That is a fraction. And remember, x, we take the bottom and set it not equal to 0. Can't do nothing else to that. So one number I got to kick out is definitely a 0. Now, once I got it put in, I still couldn't be a 0 here. Couldn't be a 0 here. But what we want to do is start getting to the final answer. Over here, my final answer had a fraction with an x minus 6 on the bottom. So we got to take that x minus 6 and set it not equal to 0. So to solve that, I would actually add 6. So that one tells me x cannot equal 6. So for each part of this that had a fraction, I have to set them equal to 0. So x cannot equal 0 or 6. Now y'all pay attention. The way we exclude numbers using interval notation, they always start at negative infinity on these, okay? So from negative infinity, you go left to right. The first number you would hit would be 0. So to kick out that 0, we're going to put 0, and then we're going to union, and then we're going to start more parentheses with the 0. So this means negative infinity can go up to 0, but it cannot be 0. And then I still can't be 0. From 0, I'm good until I hit 6. Now, since 6 cannot be included, I got a union around the 6. Now, from 6, I can keep on going until I hit positive infinity. So, to kick out a number, you got to do a union around it. So this tells me from negative infinity to 0, all those numbers worked, except for the 0 now. I'm kicking it out. From that 0 to that positive 6, all those numbers worked. 1, 2, 3, 4, 5, all those will work. But it cannot be 6, so I got a union around that 6. And then from the 6, I can go through every number towards positive infinity, and they work. So to kick out a number in interval notation, we use a union, okay? And you always go left to right on a domain. It's always going to start at negative infinity and then head off towards positive infinity. All right, that was f of g. How about g of f of x, which is like a g of f of x? First, we got to do f of x. So let's see. F of x equaled 5 over 1 minus 6x. Cannot do nothing to that. So this whole thing is going to be f of x, and we got to put it into the g. So we're going to find g of 5 divided by 1 minus 6x. So y'all, where's my g equation? It was 1 over x. So that's going to be 1 over x, which is 5 divided by 1 minus 6x. All right, so let's see what we got going on here. So I don't have to worry about this one because it's already like a single fraction. I got 5 over 1 minus 6x. So what I'm going to do is what I did a while ago and turn it into 1 divided by 5 over 1 minus 6x. Now, remember, that's like a 1 over 1. So I'm going to put 1 over 1 times, flip this one, 1 minus 6x over 5. And when you multiply that, you get 1 minus 6x over 5, final answer. So I try to get it to a single fraction on the bottom. That way I can flip it and multiply, okay? Now, that'd be your final answer. So your domain. Well, right off the bat, I got a fraction. So remember, 1 minus 6x cannot equal 0. So what I would do is subtract 1. That would give me the negative 6x cannot equal negative 1. And then divide by negative 6 so that x cannot equal a positive 1 over 6. Remember, that's going to be positive now because a negative divided by a negative. All right, so let's see. We put it in. We still had to worry about that down here. Got over here. let's see, once we flipped it, I didn't have no fractions on the bottom. So it looks like the only number we had to worry about was the 1/6. So to kick out a 1/6, interval notation, I start at negative infinity. I go until I hit the positive 1/6. Since it can't be 1/6, I got a union around that 1/6. Now, from that 1/6, there's no other numbers to worry about. So everything after 1/6 headed towards positive infinity will work. All right, y'all, so that was 9.1. So let me stop my share. So the thing, work on these. If we have any problems, we'll work them out. Hit me up, okay? So good luck.